Let us solve a question on capital labor ratio. The question is, suppose the production function is Q is equal to K raised power 0.75 times L raised power 0.25. K and L denote the units of capital and labor employed to produce Q units of output. Price of labor is $3 and price of capital is $5. We need to find out the cost minimizing capital labor ratio. Okay, so what is the cost minimizing cost minimizing condition? So cost minimizing condition is cost minimizing condition requires that the ratio of the marginal product of labor upon marginal product of capital should be equal to the input price ratio, that is the price of what we call labor upon price of capital. Okay, this is the condition for cost minimization, or to find out the cost minimizing what we call cost minimizing capital labor ratio. Now we need to find out the marginal product of labor. What is marginal product of labor? If we try to find out here, so marginal product of labor is simply the change, the partial derivative of production function with respect to labor. So we differentiate partially this with respect to L. So we have the exponent of L becomes coefficient. So we have 0.25. Then we have K raised power 0.75. Okay. Then we have L raised power. Now exponent is subtracted by 1. 0.25 minus 1 becomes minus 0.75. Minus 0.75. Okay. Similarly, marginal product of capital will be the partial derivative of the production function with respect to capital. This time we partially differentiate with respect to K. So the exponent of K becomes coefficient. We have 0.75. Then we have K raised power. Exponent is subtracted by 1. So 0.75 minus 1 becomes minus 0.25. Then L raised power 0.25. It will remain same because we are taking the partials with respect to K here. Okay. So this implies here, so MPL is this 0.25. So we have 0.25 K raised power 0.75 times L raised power minus 0.75 divided by 0.75 times K raised power minus 0.25 times L raised power 0.25. It should be equal to the price of labor, which is being given us here $3, upon the price of capital is being given us as $5. We need to solve this. So 0.25 upon 0.75, it becomes 25 upon 75. 25 upon 75, this is equal to 1 upon 3. Okay, so we can write this becomes 1 upon 3. 1 upon 3. Now what will we do here? We transpose this K to numerator. It will get multiplied here, but exponent sign will change. So we have K raised power 0.75. When I transpose this, it gets multiplied. It becomes K raised power 0.25. Okay. Similarly, what will we do? And let me see if I can write it here. I transpose this L to denominator. So it gets multiplied with this L with change in the exponent sign. So L raised power 0.25 we have times, so transposing this, it becomes L raised power 0.75. It should be equal to 3 upon 5, which implies we have 1 upon 3. Now here bases are same, we can add up the exponents 0.75, or let me write it here. We get K raised power 0.75 plus 0.25. Similarly, here bases are same, we can add up the exponents. We have 0.25 plus 0.75. It should be equal to 3 upon 5. So we get 1 upon 3. We have here, so 0.75, 0.25 sums up to 1. So we get k raised power 1, which is equal to k. Here also we get the exponent is 1. We get here L should be equal to 3 upon 5. So we get k upon L is equal to 3 upon 5. Transposing this, it will get reciprocated, okay, and multiplied, it becomes 3 upon 1. So we get here capital, what is k upon L? It is our capital labor ratio. So capital labor, so it is not visible. So we have capital labor ratio comes out to be 3 3s are 9, 5 1s are 5. So capital labor ratio will be equal to 9 upon 5. Okay, I hope I make myself clear in this video and you find out this video helpful. Thank you.